ORM is one of the most complex things that you could ever touch, and we choose it over and over again without thinking at all because everybody's doing it. It is really complex. You waste an inordinate amount of time on it, and you need to look at it. Depending on the kind of work you do, the claim that object relational mapping is one of the most complex things you could ever touch is just as likely to be shocking as it is to be blindingly obvious. Because Active Record and other Ruby ORMs provide highly abstracted ways of solving common problems, it is easy to ignore the underlying complexity involved in even the most simple things that we use ORM for. But just as there's a huge difference between operating an automobile and repairing one, the cost of understanding ORM is much higher than simply making use of it. But just as there's a huge difference between driving a car and repairing one, the cost of understanding ORM is much higher than simply making use of it. In this two-part article, I'll walk you through a minimal implementation of active record patterns so that you can more easily understand what we take for granted when we use this flavor of ORM in our projects. In this two-part article, I'll walk you through minimal implementation of active record so that you can more easily understand what we take for granted when you use this flavor of ORM in our projects. Is the active record architectural pattern inherently complex? Whenever we're talking about active record in Ruby, it is extremely common for us to immediately tie our thoughts to the Rails implementation of this pattern, even though the concept itself was around before Rails was invented. If we accept that Rails If we accept the Rails-centric view of our world, the question of whether Active Record is a complex piece of software is trivial to answer. We only need to look at the Active Record base object to see that it has We only need to look at the active record base object to see that it has all the following complecting characteristics. hundreds of instance methods, hundreds of class variables, over a dozen instance variables, over a dozen class instance variables, several class variables. A construct inherently complex. A 40 level deep method lookup path for class methods, a 46 level deep lookup path for instance methods, dozens of kinds of method missing hacks, no encapsulation whatsoever between mixed modules. But if you look back at how Mountain Farlow defined the concept of active record in his 230 book, Patterns of Enterprise Application article, you'll find that the pattern does not necessarily require such massively complex implementation. In fact, Fowler's definition of active record included any object that could do most or all of the following things. Construct an instance of the active record from SQL set row, result set row. Construct an instance of active record from SQL result set row. Construct a new instance for later insertion into the table. Use static finder methods to wrap commonly used SQL queries and return active record objects. Update the database and insert data into the active record. Get and set fields. Implement some pieces of business logic. Clearly, the Rails-based active record library does all of these things, but it also does a lot more. As a result, it's easy to conflate the coincidental complexity of this very popular implementation with the inherent complexity of its underlying architectural pattern. It's easy to conflate the coincidental complexity of this very popular implementation with the inherent complexity of its underlying pattern. This is a major source of confounding in many discussions of software design for Rails developers, and something I want to avoid in this article. With that problem in mind, I built a minimal implementation of active record pattern called Broken Record, which will help you understand the fundamental design challenges involved in implementing this particular flavor of ORM. As long as you keep in mind that Broken Record exists primarily to facilitate thought experiments and is not meant to be used in production code, it should provide a much easier way for you to explore a number of questions about ORM in general and the active record pattern in particular. As long as you keep in mind that Broken Record exists primarily to facilitate thought experiments and is not meant to be used in production code, it should provide an easy way for you to explore a number of questions about ORM in general and the active record pattern in particular. The ingredients for implementing an active record object. Now that you know what an active record is in its most basic form, how would you go about implementing it? To answer that question, it may help to reflect upon an example of how active record objects are actually used. Following code is about as simple as it gets, and so is a good place to start with any. The following code is about as trivial as can be, and so it is good a place to start as any. Following code is a good place to start because it illustrates some of the most basic features you can expect from an active record. Following code is a good place to start because it illustrates some of the most basic features you can expect from an active record object. While this example omits a bit of setup code, it's not hard to see that it produces the following output. Despite its simple output, there's a lot going on in this little code sample. To gain a better understanding of what is happening on the web, take a look at how the article and comment objects are defined. Because broken record mapping does not implement the naming shortcuts that Active Record Base uses, the connection between these objects and the underlying database schema is much more explicit. Take a look at how the articles and comments table are defined. It should be easy enough to understand how it all comes together. It should be straightforward to understand how all this all comes together. if you haven't been paying close attention to what kinds of things you would need to build in order to make this code work, go ahead and quickly reread this section with that in mind. Once you've done that, examine the following lists of active ingredients to see if they match around. Storage and retrieval of record data in a SQL database, such as article, create an article, all. Dynamic generation of accessors for record data, e.g. active record body. Dynamic generation of associations method, e.g. article comments, including the ability to dynamically look up the associated class. The ability to wrap all these features up into a single module mixin. This easily demonstrates the fair amount of complicated code is needed to support the most basic uses of active record objects, even when the pattern is stripped down to its bare essentials. But it's one thing to have a rough sense of that a problem is complex, and a different thing entirely to convey yourself with its nuances. Former insight leads you to appreciate your magical tools, the latter helps you master them. To help you dig deeper, I will guide you through the code that handles each of these responsibilities, broken record, and explaining how it all works along the way. We'll start by exploring some low-level constructs that help simplify the implementation of active record objects, and then in Initial 4.9 we'll look at how the whole system comes together. Extracting away the database. Using the active record pattern introduces tight coupling between classes containing bits of domain logic and underlying persistence layer. However, this does not mean that an active record ought to directly tie itself to a low-level database adapter. With that in mind, introducing a simple object to handle basic manipulations and queries is a good way to reduce the brittleness of this tightly coupled design. The following example shows how a broken record table can be used directly to solve the same problem that was shown earlier. As you read through it, try to imagine how the broken record As you read through it, try to imagine how a broken record mapping module might be implemented using this object as a foundation. Despite the superficial similarity between the features provided by broken record mapping mixin and the broken record table class, there are several key differences that set them apart from one another. 1. Mapping assumes that broken record database holds the reference to an appropriate database adapter, but table requires the database adapter to be injected. This means that unlike mapping, the table class has no dependency on global state. 2. Most of the methods in mapping return instances of whatever object gets mixed into, but tables always return primitive values such as arrays, hashes, and integers. This means that the mapping needs to make assumptions about the interface of other objects, and table does not. 3. Mapping implements a big chunk of its functionality via class methods, but table does not rely on special class behaviors. This means that table can easily be tested without generating anonymous classes or doing awkward cleanup tests. The mapping mixin is convenient to use because it can introduce persistence into any class, but it bakes in a few assumptions that you can easily change. By contrast, the table object expects you to wire things up by hand, but is conceptually simple and very flexible. This is exactly the kind of tension to expect between higher and lower levels of abstraction. It is not necessarily a sign of a design problem. If these two components were merged into a single entity, the conflict between their design priorities would quickly lead to creating an object with split personality. Whenever that happens, complexity goes through the roof, and so does the cost of change. By allowing mapping to delegate much of the functionality of the table object, it's possible to sidestep those concerns and get the best of both worlds. Encapsulating record data. One of the defining characteristics of an active record is that ordinary getters and setters can be used to retrieve and manipulate its data. As a result, ordinary operations As a result, basic operations on active record objects end up looking like plain old Ruby code, such as in the following example. The interesting part about getters and setters for active record objects is they need to be dynamically generated. To refresh your memory, take a second look at the class definition for article and note that it contains no explicit definitions for the article title and article body methods. In the dev code, map to table types article class to a database table, and the columns in that table determine what accessors need to be defined. Through a low-level call to broken record table, it's possible to get back an array of column names, e.g. something like ID, title, body. Through a low-level call to broken record table, it's possible to get back an array of column names as shown below. If you assume that article source field values directly If you assume that an article will not serve field directly, it's been instead delegated to some sort of value object, Ruby's built-in struct might come to mind as a way to solve this problem. After all, it does make dynamically generating a value object with accessors quite easy. Use a struct for this purpose is a fairly standard idiom, and it's not necessarily a bad idea. Despite how simple they appear to be on the surface, lesser known features of struct objects make them very complex. In addition to accessors, using a struct also gives you all of the following functionality. While this broad interface makes struct very useful for certain data processing tasks, they are much more often used in scenarios in which a simple object with dynamic accessors would be a much better fit. Broken record row class demonstrates how to implement such an object while maintaining a minimal API. The most important thing to note about this code is that the broken record row makes it just as easy to create a dynamic value as a struct does. In addition to not implementing most of the features struct provides, broken record row also does not rely on an anonymous intermediate class to implement its functionality. Another key difference Another important difference is that broken record row does not rely on an anonymous intermediate class to implement its functionality. This helps discourage the use of class inheritance for code reuse, which in turn reduces overall system complexity. In addition to these implications, broken record row also attempts to adapt itself a bit better to its own problem domain. Because broken record row is intended to be used because broken record objects need to be used in conjunction with the broken record table. They need to be more friendly. Because for objects need to be used in conjunction with table objects, they need to be more hash friendly than struct objects are. In particular, it must be easy to set the values of the row object using a hash, and it must be easy to convert a row back into a hash. The following example demonstrates that both of these requirements are handled gracefully. While it may be a bit overkill to roll your own objects for the sole purpose of removing features from an existing, well-supported object, the fact that broken record row also introduces a few new features of its own makes it more reasonable to implement things this way. More can definitely be said about the trade-offs involved in making this kind of design decision, but they're very context-dependent, and that makes them a bit tricky to generalize. The objects described in this article may seem a bit austere, but they're easy to reason about once you gain some familiarity with them. The second part of this article, issue 49, you'll be able to see this object in context with in the context which they are actually used, which will help you understand them further. The main theory I'm trying to test out here is that I believe simple low-level constructs tend to make it easier to build simple-level, higher-level constructs. However, there is a very real tension between conceptual simplicity and the practical ease of use, and that can lead to some complicated design decisions. What do you think about that? What do you think about these ideas? Are the techniques that I've shown far more confusing than they are enlightening? Do you have a better idea for how to approach this problem, no matter what is on your mind? If you have thoughts on this topic, I want to hear from you.